Arene substitution patterns are part of organic chemistry IUPAC nomenclature and pinpoint the position of substituents other than hydrogen in relation to each other on an aromatic hydrocarbon. Ortho, meta, and para substitution. In ortho substitution, two substituents occupy positions next to each other, which may be numbered 1 and 2. In the diagram, these positions are marked R in ortho. In meta substitution, the substituents occupy positions 1 and 3. In para substitution, the substituents occupy the opposite ends. The toleridines serve as an example for these three types of substitution. Ipso, meso, and peri substitution. Ipso substitution describes two substituents sharing the same ring position in an intermediate compound in an electrophilic aromatic substitution. Me3C, TBU, and IPI groups can form stable carbocation, hence are ipso-directing groups. Meso substitution refers to the substituents occupying a benzylic position. It is observed in compounds such as calyxarenes and acridines. Peri substitution occurs in naphthalenes for substituents at the 1 and 8 positions. Syne and tele substitution. In syne substitution, the entering group takes up a position adjacent to that occupied by the leaving group. For example, syne substitution is observed in Arene chemistry. Tele substitution occurs when the new position is more than one atom away on the ring. Origins. The prefixes ortho, meta, and para are all derived from Greek, meaning correct, following, and beside, respectively. The relationship to the current meaning is perhaps not obvious. The ortho description was historically used to designate the original compound, and an isomer was often called the meta compound. For instance, the trivial names orthophosphoric acid and trimetaphosphoric acid have nothing to do with aromatics at all. Likewise, the description para was reserved for just closely related compounds. Thus Berzelius originally called the racemic form of aspartic acid para-aspartic acid in 1830. The use of the prefixes ortho, meta and para to distinguish isomers of di-substituted aromatic rings starts with Wilhelm Korner in 1867. Although he applied ortho prefix to a 1,4 isomer and a meta prefix to a 1,2 isomer, it was the German chemist Carl Graebe who, in 1869, first used the prefixes ortho, meta, para to denote specific relative locations of the substituents on a di-substituted aromatic ring. In 1870, the German chemist Victor Mayer first applied Graebe's nomenclature to benzene. The current nomenclature was introduced by the Chemical Society in 1879. Examples of the use of this nomenclature are given for isomers of cresol C6H4. There are 3 Arene substitution isomers of dihydroxybenzene 2, the ortho isomer catechol, the meta isomer resorcinol, and the para isomer hydroquinone. There are 3 Arene substitution isomers of benzene dicarboxylic acid 2, the ortho isomer phthalic acid, the meta isomer isophthalic acid, and the para isomer terephthalic acid.